Okay, ladies, I'm going to give you some little helpful hints about a few of the PSAT questions on your current PSAT packet. I'm going to start with some information about problem number 18. I'm not going to work number 18, but the one I work will be very similar to number 18. It's talking about reflecting about y equals x. So this means something very simple. It means for any point that's on one of the lines, you're going to convert it to a connected point or a related point by simply switching the two numbers. So if you have the point 1, 3, you're going to switch it to 3, 1. That's all that it really means. Let me show you what that looks like graphically. So here's that x, y axis. Here's the line y equals x. That comes up at a 45-degree angle. And I'm going to put 2 points up here. Here, this is the point 3, 1. And then I'm going to go over here and put the point -2, -4. Okay? If I want to reflect those points about this line, I'm simply going to flip the numbers around. And instead of having the point 3, 1, I'm going to have the point 1, 3. And instead of having the point -2, -4, I'm going to have the point -4, -2. That's all there is to it for reflecting about. I think problem number 18 asks you to find slope. So all you want to do is flip those points over to the other side. So you're going to flip the 2 points over to this side and then find the slope of that line. Okay, pretty straightforward. All right, the next one's number 27. And it talks to you about doing the graph of the absolute value of a function. And this sounds awfully scary, but it's really, really not that bad. All that it really does is it makes all negative y values positive. That's all it does. It just takes those negative y values and turns them into positive numbers. So you can do that numerically, but it's pretty easy to see graphically as well. So for example, take a look at this graph. So here's this graph, and I'm going to make this point 2, -3. If I tell you to do the graph of the absolute value of this graph, these things over here that are already positive up above are not going to change. They're going to stay exactly like they are. But this piece down here that's got all these negative y values is going to flip up to the top like that. And that point 2, -3 will become the point 2, +3. It'll flip up the exact same height. So the black line was the original graph, and the red line is the absolute value graph. Let me give you another graphic example of what that looks like. Okay? It looks kind of like the one that you have to do. I'm going to put some points on here also just to make the idea about how these connect. The one that you have in your PSAT doesn't have actual numbers on it, but keep in mind what I showed you here. And I'll do this with a blue pen. All right? Anything that's above the x-axis, this is the x-axis right here. Anything that's above the x-axis is just, and on it is just going to stay. So that's not going to change, and that's not going to change. But these pieces that are below are going to flip up to the top. And they flip up to the same height up that they were down. So this was down at -3. When I flip it up, it's going to be at +3. And I put it here because right beside it is something that's higher than that. This down here was down at -6. When it flips up, it's going to go to +6, so it's going to go higher like this. It's going to go to the point 5, +6. So the absolute value graph is this blue line here. I'm going to go over it with red also just so you can see it. It goes up to 3, then it goes up to 4, then it goes up to 6, and then it goes up to 1. Okay? All right, so that's 18 and 27. All right? So the next one I'm going to talk about is number 19. But as I go to 19, I'm first going to talk a little bit about number 1, which I'm sure y'all all have right. This kind of question is on there a lot. 3x plus 1 equals 4. Now, don't tell you to find x. They tell you to find something like 6x minus 5. And just thinking through how you do that, you just solve for x. You know, you solve for x first. Sometimes there's a shorter, oops, that's the same one. Sometimes there's a shorter way, but this way usually works. So solve for x. And then after you solve for x, you find whatever it is they wanted you to find. So 6 times x is 6 times 3, which is 18. And then 6 times x minus 5 is 18 minus 5, which is 13, and that would be your answer, okay? Now, expanding that just a little bit, this is a little bit more like number 19, is if I said 3x minus y equals 4, and then I said find 6x minus 5. It's got that extra variable in there. You just have to hang on to it. You know, solve this for x again. So 3x equals 4 plus y, and divide everything by 3, and x equals 4 plus y, all divided by 3. And then you want to build up to whatever they've asked you to find. They've asked you to find 6x minus 5. So use your order of operations. Do multiplication first. Find 6x first. 6 times 4 plus y divided by 3. I like to take a second to simplify that. The 6 and the 3 cancel. Give me a 2. That gives me a 2 times 4 plus y. Or even simpler, 8 plus 2y. So I get that down to 6x is equal to 8 plus 2y. Okay? And then I'm going to do the second step, which says subtract 5, and I get 8 plus 2y, and I subtract 5. And again, I can simplify that just a little bit, and I get 3 plus 2y. So this would be the answer to that. Okay? Now this third one looks just a little bit more like number 19, still not quite the same thing, but just one more example. If 4x is equal to 9y, and I ask you to find for me 3x over 8. You know, the first thing to do is just solve it for x. X equals 9/4 y, step 1. And then build back up to whatever they've asked you to find. So order of operations here says to do 3x, so I'm going to multiply both sides times 3. Thank goodness you get to use your calculator, so you don't panic. Okay, and now I need to change it to 3x divided by 8. So I'm going to divide both sides by 8, and again, thank goodness you get to use your calculator. 3x over 8 equals this thing on your calculator here. Make sure you're careful with it. It's 27 over 8. That needs to be in parentheses, and then 27 over 4, sorry. And in parentheses, divided by the 8. And the answer will come up as 27 over 32y. And that should help you get through number 19. Okay? And one last one, number 36. This is about averaging a list of numbers when you don't know what the numbers are. So let me just give you an example. If you have 10 numbers that average 8.2. Okay, what you can say is that if you add the 10 numbers, here's that symbol for numbers, and divide it by 10, the answer is 8.2. And the key to these problems is to recognize what else this tells you. If you multiply both sides of this problem by 10, there, these 10s cancel out, and you get that if you add all 10 numbers, you get 8.2 times 10, which is 82. Now, I still don't know what each of those numbers are, but I know that they add up to 82. So then there's usually a second step that says, well, if you have 5 numbers that average 6.1, most is 6.2, okay, probably even better. Then you can change that to say, okay, if I add those 5 numbers and divide not by 10 this time, but by 5, that's how you average. So that's going to give me 6.2. And then if I want to get rid of that 5, multiply both sides times 5, then I'm going to get that if I add the 5 numbers, I get 6.2 times 5, which I forgot to do before I came over here. Sorry, and that gives me 40, all right? All right, so now, you take the two things together, and they ask you the question, what is the average of all 15 numbers. Well, how do you find the average? You add all 15 numbers, and you divide not by 10 and not by 5, but you divide by 15. Okay, well, I don't know what the 15 numbers are, but I know that 10 of them add to 82, and I know that 5 of them add to 40. So when I add up all 15, it will be 82 plus 40, and do that arithmetic, and then divide by 15. 82 plus 40 is 22. Divided by 15, it's probably not going to come out nice. Yeah, it came out to be something maybe 8.13333. I'm pretty sure the one on the PSAT comes out nicer than that. Okay, so hopefully those little tidbits will help you through some of the slightly more complex problems on your AP packet report.